Hi, Algebra 2, 9.2. We are going to start talking about the normal curve. The reason why we started this unit with really with combinations and permutations is because we're sort of looking at, we're going to switch into the probability that different outcomes will occur. So on 9.1, we were looking at how many different options can we have. Now we're thinking about, well, what's the probability that these different options might happen? If you have ever heard of the bell curve has a large hump in the middle, and what happens is the area that's underneath the curve is related to the probability. If you ever go out and probability and ask somebody, let's say how many, I don't know, hairbrushes or how many cars they own, most people fall on average somewhere in the middle, right? We're probably going to have somebody say anywhere from 1 to 4, maybe. You're not going to hear a whole lot of people say, I own 20 hairbrushes or cars, something like that, right? Or 0. But they probably have 1, 2, 3, maybe 4, depending on how big their family is. So there's this whole idea that there's a tendency to go toward the middle. If you ask somebody whether they're a Republican or a Democrat, that's another one. They'll tend to say they're somewhere in the middle. You're not going to have a lot of people say, I'm an extreme Democrat, completely liberal to the right, or I'm an extreme Republican, all the way to the left. There are people out there who feel that way, but most people in the world are somewhere in the middle. So any situation that you think of, most people fall in the middle. And that's why there's this huge hump in the middle of the bell curve, which now we are calling the normal curve. The normal curve is exactly like this, and it's symmetrical. So if you think about what the line of symmetry might do, it's going to completely divide this curve in half, and both sides are symmetrical. So if I said that the probability of being in the high category was 15%, well, then my probability of being in the low category would also be 15% because these would be the same on both sides. All right, so that's a little background about this curve, and we're going to go into more detail with that as we move on. In class next time, we are going to be doing a wall push-up activity. We are not going to be doing this for our notes, so you can put a star here. We're going to be getting back to that when we come to class. What I do want you to take a moment to look through are these words that you have seen. You've at least seen these first 4. This 5th one down here might be a new one for you. Take a second to reflect on what these words mean. You can think back to Algebra 1 is when they were reviewed. In middle school, we were reviewed. Remember what those words mean. So our mean, you guys also might see the word average, is when we add up all of our data values that we have, right, and divide by the total. Our median, if we arrange from least to greatest, so if you arrange your numbers from least to greatest, the median is the one that's right in the middle. So arrange from least to greatest. I've got to shorten it because I don't have so much space. We want to pick the middle value. That's what our median is. So if you've got all your data values lined up, we're going to pick the middle. The mode is the one that occurs the most. Okay? Whatever number you have in your data set and it occurs the most. So you're going to have a collection of data and we're going to be looking at what all these actually tell you. And then our range is the highest minus the lowest. So the range of values. If you think about sit-up or wall push-ups, we're going to be doing wall push-ups. We probably will have most people getting somewhere between, I don't know, we're going to do wall push-ups for a minute. So you might have most people get somewhere between like 20 and 30. But we might have some people who will get 50 or 10, right? So most people will be somewhere in the middle, and then we'll have a couple people on either end. And all of these different ways of looking at data will help us analyze what we need to know or where we compare against everybody else. So the new word for today, the standard deviation, that basically just tells you on average how far your amount of push-ups deviates from the mean or the average. So how far away on average are your push-ups from the rest of the class's average. That's really what it tells you. So deviation, remember that word just means like going away from where you're supposed to be going. Like if you're driving and you're deviating from the road, not a good thing. You're supposed to be staying straight and we're going off to the side. So that is where when you think about the deviation, we're going how far away from the mean do we deviate? So the distance, data points are from the mean, and that's again on average. So approximately how far away are they? We're going to be using some new language to be talking about this. X with the little I, and I'll rewrite it here so you guys can see it. X with this little I is going to represent our data points. So for example, if you did 30 sit-ups, 30 would be one of our data points, right? And that little I just represents which one we're talking about. You're also going to see this mu, which looks like a little fancy M. It's a Greek letter mu, and that stands for the mean. You are also going to see this summation symbol, and the summation symbol is also a Greek letter, epsilon, or sigma, excuse me, but sigma is telling us that we are adding, so it's a sum, okay? And then the last point is an N. And N just tells you how many, so it's number is what it stands for, number of data points total that you have. So for our push-up activity, if we have 25 students in class, well then our total number of data points would be 25, right? So number of data points is 25. You're also going to see these symbols in your calculator because we're going to be doing a lot of this in our calculator. So I just want to make sure you're familiar with them when you see them pop up in your calculator. So on to our first example, we're going to be looking at the normal curve, which we talked a little bit about already, and we're going to be putting in context with an example. So again, you guys can go ahead and sketch the normal curve because it will always look pretty similar. And the x-axis is an asymptote, all right? We're going to try to make both sides look the same. I know sometimes it's a little hard to draw, but this should be symmetrical, and right in the middle is going to be our mean. So what happens is, since this chunk in the middle is the biggest, the probability of anybody being somewhere here in the middle is about 68%, okay? So the chance that when you talk to somebody, whether it's about push-ups or any topic, that they're going to tell you some answer that's around the average answer that you're going to get, 68% of the people will tell you something in between here, okay? Then you've got a little chunk of people out here to the side that will tell you something different. And basically, the 68% now will jump to, so from here all the way to here is 95%. Well, to figure out what that difference is, if you guys take your 95 minus 68, right? How much will that really leave you left over for those two little chunks on the side? So 95 minus 68 gives you 27% that you've now added here and here. So if I divide that by 2, that's about 13.5% that's on either side. So that's 13.5%. And over here is another 13.5%. All we're doing is just adding up this area. Oh, 13.5. And then there's some people who might tell you something way off. And that is going to now include this last little chunk, these areas here on the ends, and that will give you a total of 99.7. So basically, if you think about all the different answers that people could give you, there's a 99.7% chance that they're going to give you some answer that we have here, right, or some number that we have here. So again, 99.7. We went from 95 to 99.7. So if we do 99.7 minus 95, that'll give us 4.7. We divide that by 2. It's about 2 super small. I have to draw an arrow there. I can't write it in there. About 2.35% chance that you're going to answer something that's out here on the side. So it's really, really small. So in other words, if we add everything together, all these areas, we come close to 100%. It's going to be 99.7%, okay? So your chance of being in the middle is 68. Your chance of being From this first standard deviation to here is 95, and then from the third chunk is 99.7. Just to show you guys, right here in the middle is your mean. If I add one standard deviation right here, okay, this is one standard deviation away, and here's another standard deviation away. So within one standard deviation is a chance of 68% to fall between one standard deviation. If I add another standard deviation, so now I've added 2 standard deviations to the right and 2 standard deviations to the left, now my chance of falling in here is 95%. If I go out 3 standard deviations, so 3 to the left, here's 1, 2, 3, or 3 to the right, 1, 2, 3, that's 99.7% chance. Okay, so we only go out, we add standard deviation 3 times to the right and 3 times to the left, and that gives us almost 100%. So just a little extra information about your curve here. Let's see what this actually means in an example. In 1972, the heights of rugby players were found to be normally distributed. So notice how the problem will tell you it's a normal distribution, which means they've collected a lot of data to make sure that it will fall like this normal curve looks. The mean is 179 and the standard deviation is 7. So what I'm going to do is I'm going to sketch my own little curve here. Ooh, and I'm going to try to make it look as neat as I can. That will not always look perfect. And my mean is 179. I'm going to put that right in the middle. And I'm going to add, this is my standard deviation of 7. So I'm going to add standard deviation again. Remember, we go 3 times to the right, 3 times to the left. Right is positive, so we add. Left is negative, so we subtract. So we're going to come here. 179 plus 7. So I now have 186 centimeters. I'm going to add again 186 plus another 7. So that is going to be 193. And then I'm going to add one last time. 193 plus 7 gives me 200. Now I'm going to subtract 7. I'm going to go to the left. So from, again, here's my mean, here's in the middle, just so I don't lose sight of where my middle is. I'm going to subtract once to the left. So 179 minus 7. So I'm going to be at 172. I'm going to subtract again. 172 minus another 7. I'm going to be at 165. And let's subtract one more time. 165 minus 7 will be 158. Okay? So my chance of being in one standard deviation, again, this should be the 68% that we were talking about over here. So let's see what our questions are asking us. What percent of data falls within one standard deviation? Well, we know that to be 68%. Okay? What percent of data falls within 2 standard deviations? Well, we know that to be 95%. And then what percent of data falls within 3 standard deviations? I know that is 99.7%. So now, looking at our rugby players, find the percentage of rugby players that are between 172 and 186 centimeters tall, because we're talking about their height. So let's look back at our picture. 172 to 186. Here's 172, here's 186. Well, what percentage is from 172 to 186? That looks like we are 1 standard deviation away, so it looks like it should be 68%, and you guys are correct. Number 2 is asking you, find the percentage of rugby players between 165 and 193. So let's look back. 165 and 193, that looks like it is 2 standard deviations to the left and 2 standard deviations to the right. Well, we know 2 standard deviations gives us this 95%. So that means 95% of rugby players are somewhere between 165 centimeters tall and 193 centimeters tall. Find the percentage, number 3, find the percentage of rugby players between 172 and 179. So let's look back. 172 and 179. Ooh, that looks like it's just half of the 68, right? So half of 68 makes 34. And then last but not least, If 50% of the rugby players are taller than K, what's the value of K? Well, if half of my rugby players are taller, then I know I'm in the middle, so 179. So we'll get to look at our normal curve a bit more in detail next time.